A warm greetings to everyone. I am D.M.KALAI SELVI, CSE Department, RMD Engineering College. Now we are going to see about feature extraction in machine learning subject. For doing feature extractions, the various methodologies used are principal component analysis, singular value decomposition, otherwise called matrix factorization, linear discriminant analysis. Now we are going to see about principal component analysis in detail. So we expect machine learning algorithms to use less features comparatively to other algorithms so that it can be able to achieve the consistency quickly. So in PCA, we can derive a new set of features which are extracted from the original features which are quite dissimilar in nature. So for example, if we have n-dimensional feature data set, which we can convert it into m-dimensional. That means n value, for example, taking n as 10 value, your m value, you can take it as 6 or 7. So that means your m value will be less than n. We are reducing the features such that the dimensions are orthogonal in nature, that is completely independent to each other. The features dimensions are completely independent in nature. For doing that one, we use a property called vector spaces. So what here you will be doing is you represent as a linear combination of smaller set of vectors called basis vectors. The formula for vector space is V is equal to sigma I equal to 1 to n ai ui, where A represents n scalars and U represents the basis vectors. So what basically the principle behind the principal component analysis is linear combination of basics vectors helps in decomposing the vectors to a number of independent components. That is, the components will be converted in an orthogonal manner such that it is independent to each other. The feature vector can be transformed to a vector space of the basis vector, which we termed as principal components. The objective of a PCA will be the new feature should be distinct. The covariance, that is the covariance between the new features should be 0. The new feature we use a term called principal component. The first principal component should capture the maximum variability and the second principal component should capture the next highest variability. The sum of the variance of new features or principal component should be equal to the sum of the variance of original features. Now we are going to see what are the steps involved in PCA. So basically, PCA, principal component analysis, works on the idea behind eigenvalue decomposition of a covariance matrix. First, we have to calculate the covariance matrix of a data set. Next, we have to calculate the eigenvalue of the covariance matrix. Next, third step will be the eigenvector having highest eigenvalue represents the directions in which there is a highest variance. Fourth step will be eigenvector having the next highest eigenvalue represent the direction in which data has the highest remaining remaining variance, and all the principal components should be orthogonal in nature. At last, we will be taking the top k eigenvectors which are having the top k eigenvalues, which will represent the k principal components. Thank you.